All right, can you all hear me okay? Okay, all right, cool. Um, so this probably won't be a long presentation. It wasn't for the last group. I want to talk about the lab and the write-up and answering your questions. And then I did make a mistake at the end of class today because I was in a hurry. Let me go and show you the PowerPoint slide. I was talking about this slide really when I meant to talk about this slide. So this is the problem I want to do on Monday. Okay, so one thing I need to talk about, it won't take me more than 5 minutes. I want to talk about what happens when you discharge a capacitor. So I'll go very quickly. I'm not going to derive the equation. I'm going to state the equation for discharging the capacitor. So I'll do that along with discussing the lab, and then that's it. Okay. Let me go to the lab document. And stop me if you have any questions. So, and I sent you an email the other day. There is no part 4 for this lab because we unfortunately did not put a diode in your lab kits. Okay. That was a good opportunity to have you get some practice on wiring circuits. In addition to know a little bit about the diode, what it does. Okay. So we're going to skip part 4. Our lab report is going to be on parts 1, 2, and 3. Before I talk about the lab, I wanted to mention something about the power supply you are using for this experiment. So let me change views. The power supply that you're given, the adapter looks like this, okay? And it actually has, and for some reason I can't count, there's actually 7 voltages settings, not 6. For some reason I counted 6, okay? So in your data table only has rooms for 6. So if you either take 6 sets of data or 7, that's fine, okay? The other end of this device that you see here has this connector. Now, when I talked about the lab, I assumed that this was already assembled, but it's not. Okay, because I was given this was given to me already assembled. So when you open up the box that this is in, there's going to be a bunch of connectors that go onto the end of the adapter. One of them is this guy that has a green end to it. This goes into the little adapter. So this snaps into place. And then you got to use wires, and you actually got to screw the wires in. There's little little screws here. So you need a screwdriver. Either Phillips head or regular screwdriver will work for you. Okay, so you can hold the wires in place. All right, everybody clear on that? I just want to make sure that's clear so you can actually run your experiment. Okay. All right. So let me talk about the experiment itself. And again, as you do these labs, let me know what else you think would be needed to help you do the lab more easily. Let me change views again, sorry. This should be a fairly easy lab report for you because we're not doing part 4. As you go through here, we talked about this part last week, so this one's straightforward. But when you go to part 2 and you enter the information in part 2, you want to fill in this blank, you want to circle or bold, or you can actually change the color if you want to make it obvious which one you chose. Okay, you can do something like that. This data table, make sure the units are correct that you enter. Why does it say title there with a question mark? Yeah, you need to put your own title, okay? I want you to put your own title. I mean, when I grade these labs, I'm going to grade the written labs a lot more. I'm going to be a lot more picky than the video labs. Because the video labs, they're a little bit harder to set up, etc., especially with the camera. But I'll be more picky with these. So make sure you enter everything properly. For example, one of the mistakes students make is they'll do something like this. Okay, so I think that was the current that most people measured for the bulb and the multimeter quiz. If you left that like that, I'm going to write a comment like, "Wow, I'm surprised the wires didn't melt because 223 amps is extremely high current." People overlook the units, so you got to make sure that the value you put in and the units, they correspond, okay? Because otherwise the reader is going to look at this and say, "Wow, you have 223 amps through a little cable. Something's wrong. Something wrong must have happened." Okay, so just be careful with the units. And you can always change the units up here. You don't have to leave those. So you fill in the blanks. Fill in the blanks here. Your graphs will have title. The axes will have labels. Then you're going to have your curve fitting parameter listed on your graph. And if you're using graphical analysis, it should do it on its own. So these are things I grade on. And then you should have a figure caption for each graph. Okay. So those are things I'm looking for. So I'm a lot more picky on these kind of labs. And look, most of you folks have had Physics 205 here, and you know how we do the lab reports. And between each faculty, each of the full-time faculty in our department, we're pretty much consistent in what we expect from you folks from the lab reports. Okay? So don't think we're going to really ask for something. If you did air propagation last semester, you will be doing air propagation this semester. And when you take 215 with Harris, he will expect the same thing. Okay. In fact, this is the course where you do the least amount of air propagation in the labs. Okay. As you go through part 3, let me go to part 3. Same thing, you have your title. And I only have room for 6. If you want to add a 7th one, you go to the end of the table, hit return, and you can put a 7th one if you want. It's up to you. There are 7 dials. For some reason, I didn't count 7. Okay, that's my bad. Enter values here. We're skipping part 4. And then in the results, you put in your results. And for part 3, the conclusion I want you to write is basically, what did you get out of the part 3? I'm not looking really for a formal conclusion here. And in fact, there's really no labs where I have you do a formal conclusion. Most of you folks got a sample, y'all got a sample lab report. And that one does have a formal conclusion in it, so it gives you a good idea what I expect in the formal conclusion. Okay. But there's really, because of the structure of the course this semester, there aren't anywhere I have you write a formal conclusion. Most of the labs that we have this semester involve you wiring something. Make sure you go over that example lab that I sent you. It should look similar to what you had to do in Physics 205, the previous course that you took at Sierra College. Does anybody have any questions regarding my expectations on the written labs? No questions? So Tyler is in the process of creating a video for this lab, at least to show how to assemble that power supply for you. So this should be placed on YouTube soon. I will give you the link when he's done. And I do want to use this time to answer questions you have on the labs. So really from now on, the labs, most of the labs will be at least 2-week labs. And so the first week I'll present the lab. The second week, I need to use it to answer your questions that you may have on the lab. So I need you to ask me questions if you're stuck somewhere. You need some information, because otherwise the lab sessions will be short. Or if we're behind, I will use the lab sessions to catch up on lecture. Okay. So maybe, based on the lack of response, not everyone probably has tried doing this experiment yet, which is fine. But in the future, going forward, you kind of want to try the labs ahead of time. So if questions come up, this is a good time to ask them. If you want to email me a question about the lab, I think I really recommend that you place it in the discussion board for your section. And then I can answer it. Because every time you put something in the discussion board, I do get a notification. Okay. So please go and use the discussion board if you have a question on it. If you send me an email regarding labs, what I'll probably do is answer your question, but then I'll post your question anonymously in the discussion board, so that if I get the same question again, I won't have to answer it. Either one's fine, Morgan. I know the problem with an email is I respond to one person. When I use Discord or the discussion board, I can respond to a lot of people. So either one is okay. But if I'm going to post somebody's question, a question that a student emailed me, I'll put it on the discussion board. Okay. And if there's a question on Discord, then because the stuff on Discord goes to, more students will see it. If it's significant enough, I'll put it on the discussion board too. Is that okay, Morgan? I don't want to discourage you folks from using Discord, because I like how you guys work, how you guys help each other on Discord. I really like that. So I don't want to discourage that. Other questions? Concerns? Your exam is next Wednesday. Okay. So if you don't have any questions, what I'm going to do is talk about the last part of my RC circuit. Really, I'm going to talk about the discharging circuit, and I'm not going to say a lot. And I was alluding at the end of the lecture to this figure, thinking it was the last problem, but really this figure basically used to describe what happens when a capacitor is discharging. So suppose I have a circuit like that. I close switch S1, let the charge on the capacitor build up. So I wait a long time. Doesn't have to be an infinite amount of time. I wait a long time until the capacitor is charged. Then I open switch S1 and close switch S2. What happens? What happens is the capacitor will start discharging through the resistor. So the energy that's lost by the capacitor is used up by the resistors. I really should have one resistor in my circuit, but that's okay. So the energy that's delivered by the capacitor goes to the resistors, and the resistors use up that energy. And the question is, what does Q look like as a function of time as the capacitor discharges? Well, you have to set up the loop rule again, like I did earlier today. The only difference is that there's no power supply in this loop. And so you're going to have the voltage drop across the capacitor plus the voltage drop across the resistors equals 0. And then you integrate. The integration, actually separating variables in this particular case, is easy. You integrate and you get an expression for Q. So that's in your note. That's in the next slide. I'm skipping. Okay. And so when you do the math, what you'll get is the following equation. So this is the equation for the case when the capacitor is discharging. So at t equals 0, the capacitor is fully charged. At t equals infinity, or you can say a long period afterwards, the charge in the capacitor is essentially 0. And so you see this decaying exponential for the total charge. And then again, defining the time constant as RC, we can write this expression in terms of tau, as you see here. If you take the time derivative of the current, if you take the time derivative of the charge, you will get the current. When you take the derivative here, you're going to get a 1 over RC out of here. And again, Q max is C delta V. The C's cancel, and you get delta V over R. That's your I max. The minus sign that you get from the equation represents the fact that the capacitor is discharging. After one time constant, this exponent in the exponential becomes 1. In other words, when t equals tau, the exponent becomes 1. E to the minus 1 is 0.37. After one time constant, the charge on the capacitor is 37% of its original value. In fact, the current is also 37% of its original value. So this is the case when it's discharging. So really, that's all I want to say about discharging the capacitor. So this equation is for the capacitor discharging compared to the case where the capacitor is charging. Let me go back some. Went too far back. This is the charging capacitor. What size are the time constants of the order of? That's a good question. It really depends on R and C. All right, it depends on the products of R and C. So let's say, I don't know, I'm going to make up some numbers. Capacitor is 1 microfarad, and the resistor is 1 megohm. Then RC is 1 second. Okay. And you can vary, the number varies depending on what you choose for R and C. So for example, in your intermittent windshield wipers, you can change how long it takes for the windshield wipers, how often you want them to turn on. That's basically you have an RC circuit in it. So you're changing the RC time constant when you're going from one setting to the other when you're intermediate windshield wipers. You're changing R. Typically, you're changing R. So R times C could be fairly small value, could be very large value. Yeah, C is the capacitance of the capacitor, and R is the resistance of the resistor. That's it. And we're ignoring the wires. Typically, the resistance of the wires is negligible. Yeah, for the demo I did with the 1 farad capacitor and the light bulb, that time constant was quite large because we had a 1 farad capacitor and the bulb was maybe the one I used was probably maybe 3 ohms. So we're talking a 3-second, maybe 3 to 4 second time constant, which is unusually large. The lab that the demo I did in class today, the capacitor was 1 microfarad. Let me double check here. The capacitor was 5 microfarad, and the resistor was 1,000 ohms. So the RC time constant was about 5 milliseconds. So it just varies, right? That number varies. Oops. Okay, it looks like we got disconnected. We're back.
This meeting is being recorded.
Okay, it looks like we're back. So we got disconnected. So then when you go to Zoom, Confer Zoom to look at the video, you're probably going to see 2 videos for this lecture. Okay? My internet's probably bad right now. So in the interest of my bad connection here, and I don't want to lose you guys again here, do you folks have any other questions? Okay, so I do want to point out again, the Sierra College Physics and Engineering YouTube channel.
The recording has stopped. This meeting is being recorded.
Okay, I'm not sure what's happening there. So there's Sierra College YouTube channel for physics and engineering. So Tyler's putting a lot of demos on that site. So you might want to look at some of the items he has there. There is a lab that I did last semester where Tyler performed the experiment and the students were given the data. It's on magnetic forces. And we can't do it. You can't do it in the lab kit because the currents that you're using in that lab are like 20 amps. Your meters can actually go to 20 amps. No, I didn't send you that one. You talking about the YouTube channel, or are you talking about the link? I'm not sure I understand your question. If you're talking about the link to a video, I haven't given you the magnetic force one yet. So the lab I skipped, it measures the force between 2 wires. You got to run around 20 amps. Your multimeters will actually can go to 20 amps for like 10 seconds. At least for sure the big one does. In fact, if you look at the manual, it says you can do 20 amps for 10, you can do above 10 amps for like 10 seconds. They're not fused. Okay, those multimeters are not fused on a 10 amp scale, which scares me. But anyway, we don't have the equipment to do that lab because you need expensive equipment. It's kind of a cool lab, but unfortunately we're skipping it. But the video is on the YouTube channel, so you can take a look at it. It's on magnetic forces. I talked about it with the previous group, so I thought I'd mention it with you folks. Do you folks have any other questions or concerns? The lab's going okay for you all? Have they been doable? I need to know all this because I have to order the equipment for next semester already. Okay, so no news is good news, I guess. All right. So if nobody has any questions, I'm ready. I'm done then. So if I don't see you in 210R, have a good weekend. So, okay. So since you made that comment,
Yeah, I can probably elaborate on that a little better with the microphone.
yeah, go
Can you hear me?
ahead.
Yeah, so like when we had to make the electrophorus and electroscope, I had like a lot of trouble getting the charge on. I don't know if it was just me. Might have been something I was doing wrong when I was charging like my the saran wrap, or like when I was approaching my I think it was electrophorus or the electroscope with like my PVC pipe. I would barely get movement, and sometimes like I wasn't too sure if it was me moving, the table, or it was a little hard to record it, if that makes sense, or record my measurements.
Yeah, and it is true that the electrophorus is a little more difficult. Even when the class is on ground, students have difficulty with it. But if you fiddle around long enough with it, you can get it to work.
Gotcha.
Yeah, that one, you're right though. That one's true. That one's true in general. Students have a harder time getting it to work, but you can get it to work. So
Sure. Okay, I was just worried it was just me, but yeah, like the one with the multimeter. I mean, that one worked flawlessly. Like you just plug in and work with it, and you were like able to see the results. So.
yeah, okay, well that's good. I mean, as long as you can see it, and I was just happy as long as I saw the results.
Oh, cool. All right, gotcha. Thank you.
So the wires are a little bit stiff, and that's true. And it's something I got to mention to Tyler. And again, the wires I was given before they were ordered were not as stiff. So I apologize. We're working on that. In fact, we're going through this week and starting to order stuff for next semester. So I'll email him and let him know. So regarding the video, yes, some of the videos were long. Some of you guys are experts at making videos. I can tell. You have experience making them, and so I'm not. When I grade the videos, I don't grade them based on how long they are or anything. I based on did you do what you're supposed to do. I do recommend, and again, I haven't had time. Some folks have been actually filming things on Canvas and just providing me a link to the Canvas studio, and I've been watching them. A lot of people have been putting their videos on YouTube. As long as they get the link, that's fine. You can, if you don't want people to see your YouTube video, just make it unlisted, send me the link, and I will be the only one who'll be able to see it. It is way easier because I had several labs videos that were like 2 or 3 gigabytes. They take a long time for me to download onto my computer. And part of the reason why those were long was because they didn't use a screwdriver. They're having a hard time with making the connections. So we're going to try to provide alligator clips to make that a little bit easier. If the video was a little long, that's fine. But the only thing is, try to put it on YouTube. Okay, if your video is long, see if you can put it on YouTube instead of having me download it, because that takes a long time sometimes to download. When I upload my lectures are about 10 gigabytes because I'm using a Mac. It takes forever to upload them because I don't have the greatest internet. So I can imagine a 3 gigabyte takes a while for me to download. But if you put it on YouTube, of course, for you, it's going to take a long time to upload.
The recording has stopped.
Okay, can you guys hear me?
This meeting is being recorded.
Okay. Yeah, I don't know why I just said it said that 99. It always said 99%. Did you hit like refresh or something or to see? See, I don't know what happened in your case. Somebody else used something called Streamable. And that worked fine too. I don't know how familiar folks are with Streamable. I mean, it doesn't have to be YouTube. You can try different.
The recording has stopped.
I'm having all kind of problems. You guys can hear me, right? Okay. I don't know what's going on. You can try. You don't have to do it on YouTube. Just give me whatever you use. Just give me the link. What's the other one? Is there one? There's Twitch, right? Isn't there one called Twitch? Or is that just for streaming? You can use whatever. I mean, it doesn't have to be YouTube. Whatever works best. But YouTube is the common one. So Twitch is more for streaming. Okay. I know there's other systems you can use. One of them, somebody sent one through, it was called Streamable.
This meeting is being recorded.
Okay, my Zoom is going crazy. And if you can't get it to work, then fine, I'll download the video. That's fine. I'm sure that if your video is long, it takes a while to upload to Canvas because Canvas is slow. Any other questions or comments? All right, you're welcome. So you all have a great weekend.